Hello everyone, this video is to go over some of the statistical information that we can get out of at risk. In class I kind of hand waved it a little bit and I just want to go a little bit more deeply into it because of questions it's going to ask you in the homework. A lot of this stuff can be duplicated using Excel functions. It's a little bit more difficult, but it still can be done. And if you think back to 687 as we talk about this stuff, you probably can remember all of the wonderful formulas that we did to do all of this, but once again, at-risk makes it really simple. So what I want to do here is, this is the sheet that we worked on in class. I want to go over here to where the demand is, because this is where my risk formula is. And in fact, let's take the round off of it. Not that it really matters. Actually, it isn't really going to matter because we're going to be looking at the distribution itself. So if I go on here and I click distribution, now since I already have the distribution there, you see the blue arrows pointing to the demand, here's all of my information on that distribution. So a lot of this is really easy to go and grab because if I look over here, I can see the mean, median, mode, standard deviation, all these other statistics, including all these percentiles, which will be my percentiles for the distribution. So remember, so this distribution is a normal distribution with a mean of 200, a standard deviation of 45. So if I go look at the 40th percentile, 188.6, I'll go put that here. I can go type this in, 188.6. It slides the line over, so 188.6, that's the 40th percentile. What does that mean? That means that 40% of all the data is to the left of that number or is smaller than that number, which you can see right here in our graph. It actually is showing that for me. So how would I do that in Excel? Let me close out of this. If you remember, we could sit there and look at our actual functions for norm. So we have norm.dist. So this is our normal distribution. So we feed in the number. It gives us we give it the mean and standard deviation. We tell if it's cumulative or if it's discrete, and it will come back with that percentage. So in this case, we did 188.6 is the number we're looking for. The mean is 200. The standard deviation is 45. And if we remember, a normal distribution is a continuous one, so we want to make sure this is true. So if I go and I type it in this way, you can see Excel will give me the same thing, that 40%, that 40th percentile. And so that's a way that we can do it in Excel. Truthfully, the statistics right out of at-risk make it really quick to find that stuff. So something else, because the problem's going to ask you, well, what if the number is, actually, let me go and label this here. So this would be the probability if X is less than 188.6, which is 40%. And so remember, if we wanted to do in Excel, if X was greater than 188.6, what would we do? Well, since this equation, the normal DIST equation, only gives you things smaller, you'd want to know bigger. Well, then we would just go 1 minus, and then we would do the norm.inverse, or excuse me, norm.dist, 188.6, with a standard deviation of 200, a mean of 45, and a true condition because it is continuous. And so we would have 59.999% that would be greater than it. And we also did this math here. So what if we wanted the probability of X being greater than 188.6, but we also wanted it to be, we wanted it to be less than 400. So 400 greater than X. So how do we calculate out this probability? Well, first we'd find the probability of being greater than 400, and we'd subtract from that the probability of being the probability of being less than 400, and we'd subtract from that the probability of being greater than 188.6, and that would give us the probability that we would end up within that range. And you would do that just using the norm DIST equations, just like we would here. So if we go back to our distribution, so let's say that we wanted to find out the percentage of results that were between 188.6. We'd type that in, and over here we'd type in 400. And that was a bad call because it's maxed out. So let's go 250. Okay, so the percentage of items that are below 188.6 right here, 40th percentile. The ones that are above 250 would be 13%, but right here between 188.6 and 250, 46.7% of the results are going to reside within that band. So once again, this is a really easy way of generating statistical information very quickly. Now, there's a lot of other things that it will do. We'll actually dive a little bit more fully into some of the more higher end stuff in the next class, but I just did want to go over this and make sure that everybody understood how to do this manipulation, because it'll be very handy for the homework. Technically, I guess if you wanted to do it this way in Excel, you should end up with the same answers. I'm not going to guarantee it, though, because it is really geared towards the at-risk, and that is something that you're being assessed on the final, so it's a good idea to delve into that and play around with that a little bit. Anyway, I will see you all in the next class. If you have any questions, please let me know.